All right, today's notes are pre-recorded, so I guess that's good for you, right? Um, Good for all of us. I gotta stay off my foot. It's getting better, but it's because of the fall I took Monday night. I really need to stay off of it because of it's all bruised there. So it's just it's getting better. It's hard to explain. The wound itself looks good, but yeah. So I kind of cut myself with that fall. I'm actually gonna here. Let me grab this. I'm gonna wear this just so that you guys don't see my um, my cuts all over my hands. I think they might be distracting because a blue glove is not. So today's notes are on polynomials. Of course, our topic is polynomials. We worked on the we're supposed to do long division. I'm gonna wait for that after the break. It's such a that one I need to be in the room for and need to take questions. I purposely chose like something that is like kind of low hanging fruit for you guys to take notes on today. So the difference of two squares is just that. It's factoring, but it's basically recognizing when you can do a quick factor. Like, you know how we do the X method. We did the AC method to factor quadratics. But now with polynomials, we don't have to just factor quadratics. Like what we do is we're looking for shortcuts on how we can factor polynomials so we can make our lives easier and do all kinds of other things, okay? So factoring polynomials is, it's tricky. Because there's so many different kinds of polynomials. It's not just quadratics. It's all of them, right? And so what we're going to do is we're not just going to we're going to start off with quadratics, but then we're going to build and give you a couple examples where we're going to step outside of the quadratics and we're going to look at actually polynomials of a much higher degree, but we can still factor them, okay? All right, so let's start off real quickly with, and I'm just going to do example after example. Let's see, I got 1, 2, 3... Yeah, I got nine different examples that are all very short, okay? And then you guys will be right in line to do, to knock this out of the park. It's really quite simple. Okay. All right, so let's say we got this guy right here. Now, first of all, we see that it's a quadratic, and you might just be inclined to do the X method immediately. And what would happen is you would find that, I need factors of negative 25 that actually give me 0 because there's no middle term there, okay? And so you might actually notice, though, that, but actually I need factors, that 4 is there too, though. So that's larger than 1. So I need factors of negative 100 that would give me 0, okay? But there's a quicker way to do this, okay? If these two conditions apply, okay, where you have subtraction in the middle, and these guys here and here are perfect squares, okay, then this actually equals the positive version and the negative version. And like that, okay? They equal that immediately. There's it's faster than the X method, okay? So what does this mean then? Okay, what we want to identify, though, is we definitely see that this is subtraction, but we have to ask the question, is this a perfect square, and is this a perfect square? Now, just because it has an X doesn't mean that it's not a perfect square. What we're going to do here is we're going to identify what's being squared in both cases. Now, you'll only have to do this the first couple times, and then you will stop labeling A and B. But remember, this right here is the difference of two square rule, okay? So what is being squared for this first term? Well, clearly we see 4 is a perfect square. In fact, he has to be for this to work. And I know that would have to be 2. And then the x squared, well, x, if he was squared, would give us x squared, obviously, right? So the perfect square, okay, of 4x squared, his square root is 2x, okay? We look at this guy, and it is 5, okay? Because 5b squared, in this case, is 25, so the b has to be the square root of that, okay? Now that we know the a and the b, we literally just do this. We got the positive version, and then we got the negative version. We're done, okay? So again, if you see two perfect squares, and they can be anything, okay, as long as they're perfect squares, shut up. And if you have, Obi, he's like getting so annoying. He's like barking at every stupid thing. Actually, I think my wife's home though. And if you got subtraction in the middle, okay, then you can execute this, okay? But he's got to have this rule. It's got to look exactly like this, and you can do that, okay? All right, now this is going to speed up, okay? Watch. You got 100x squared, perfect square, and we got minus 9, okay? Now, just quickly ask yourself, what's being squared here, okay? We know that this guy, the square root of 100 is 10, and x squared, well, that's just going to be x. So we've got 10x, okay? And 9 is a perfect square as well. So we should have plus 3, okay? And then the other will be 10x minus 3, okay? And that's it. It's like you are just recognizing the pattern and spitting out that pattern. Now, we don't know why this is useful yet because we haven't been trying to find the zeros of polynomials. But when you are trying to find zeros, factoring is incredibly easy. But you'll notice that these are all just one-step problems because, again, you're just identifying the pattern, okay? Well, let's say, what if this was reversed? What if it had 9 minus 100x squared? Well, the pattern is still holding. It just means that these guys are in different locations. So let's go 3 plus 10x, okay? So now their positions have switched. 3 minus 10x, right? That's all. So same thing. These guys, the order doesn't matter, but this, the order definitely does matter, okay? Now, if you wanted to be a weirdo and do this, okay, you could, but they don't look, you don't have to, okay? You don't have to. Just keep it like that and you're all set. Okay, so let's just keep going. What else happens? What else can you encounter? I'm making videos. All right, so you can see, well, 3 is definitely not on our list for a perfect square. 75 is definitely not on our list for a perfect square. So what we're going to do is we're going to see if we can make them into a perfect square. Can I take a 3 out of each of these? And the answer is yes, I can. I can take a 3 out of the first one, and I can take a 3 out of the 75. And so now this is just like this pattern right here. Yeah, the boys are in their bedroom. Okay, so now this guy is just x. This guy's a 5, so we'll put, oh, by the way, it doesn't matter what order you put these. If you wanted to put a minus b first and then a plus b first, that doesn't matter because, remember, multiplication is commutative. So we can switch the order of those any way you like. It never matters, okay? That matters, the order of subtraction, but the order of multiplication between the two sets of parentheses, that doesn't matter, okay? But inside the parentheses, the order here does matter because it's subtraction, okay? Okay, so that guy's factored. That's it, okay? More. Well, in fact, I only got a handful. What have I got? I got 5 more, and again, these are all quick. And we just want to recognize these patterns. I'm still in the quadratics. I haven't gone to like higher degrees yet. But you can see I can have more than one variable. It doesn't matter. If it's a perfect square, it'll just follow the pattern, okay? So I just asked myself, what's making this 16x squared? And that would be a 4x. But what's making y squared? And that would be a y, okay? So make sure that I just have the positive and the negative version. And again, the order doesn't matter. If you wanted to write this, that would have been just as fine, okay? Either one of these pairs are correct, okay? All right, next. All right, what do we got here? We got 16x squared plus y squared. Okay, so clearly we got 4x. And then we got a y. Okay, but stop. That is not what I have here. That's supposed to be the difference of two squares. It does not say the sum of two squares. So if you ever see sum right there between two squares, believe it or not, you actually can't do anything. This is non-factorable, like immediately. Okay? Unless you can take a GCF, it is not factorable at all. Okay? All right, we got a few more here. I'm actually just going to make one video here. All right, 8 to the 4. Okay, now we're going to a higher degree polynomial. Now we're outside of quadratics. So this is where it gets more important for us, okay? But the idea is still the same. Just ask yourself, what is being squared here? What's being squared here? Now the answer to this one right here is just think about the degree and then just divide it by 2, okay? So a squared is what's being squared to get a to the 4th, okay? Then what we do is we look at this guy. His square root is 5. So a squared minus 5, and then a squared plus 5. Now, what we also have to do, though, is when you are working with higher degree polynomials, once you cut them in half, you might be able to cut them in half again. So you might actually have the difference of two squares 2 or 3 times. Hopefully, you'll never have to have 3, but that has happened before in calculus. So this, luckily, that is not a perfect square. 5 is not a perfect square. So this guy is done. This is a sum. So that he's not factorable anyway. So this guy I would ignore. But this guy is done. Okay. So these guys are cooked. You are all set. Okay. So again, don't worry about a higher degree polynomial. Just cut it in half because we just want to see what's being squared. Okay. All right, I just got 2 more, and in fact, I can actually squeeze them on this paper because this kind of process is quite, it's just really just pattern recognition, recommendations of recognition. Yeah, I don't know. My wife is correcting me over there. I don't know what I'm saying. All right, okay, cut it in half. Okay, cut this guy in half. All right, and just ask: are these 2 perfect squares? Answer is absolutely not. Okay, this guy don't care because he's addition, so we leave it. Okay, so this guy's also done. Okay, now I'm gonna go to the other side here, and this is the last example, and this is pretty much as hard as you would see on the SAT. Okay, and as pretty much as high of a degree that we would use in a calculus class. So let's cut this guy in half. We know that x to the 4th squared would give us x to the 8th. We know that y to the 2nd would give us y to the 4th if we squared it. So here's our 2 squares here, the difference of 2 squares, but this guy's done because he has a sum. But over here, you will notice that we have the difference of 2 squares again. This happens sometimes, not very often, but what you want to do is you want to keep the process going. So I'm going to cut that 4 in half. I will cut him in half. Okay, so these guys produce this when I do the difference of 2 squares, but just don't forget about this guy. He cannot be cut in half in any way. Okay, I did push record. Okay, for a second I thought I did not push record. I was gonna lose my mind. All right, so now this is addition, so this guy just sticks along for the ride, and that's our finished factorization. All right, this is as hard as they get, and this is really the reason why difference of 2 squares is usually reserved for chapter 3 for polynomials, because we can reach those higher degrees and factor them quite quickly. Okay, that's the game. The handouts are available to you probably shortly, and enjoy.